Yeah, good evening all. Now I would like to discuss about network elements. Okay, network elements are classified into majorly 8 types. Okay, first one will be active elements, second one will be passive elements, third one will be unilateral element, fourth one will be bilateral element, fourth one will be lumped elements or lumped parameters, distributed elements or distributed parameters, seventh one will be linear elements, eighth one will be non-linear elements. Okay, now we will discuss each and every one clearly. Okay, first is active element. Okay, here active element is nothing but the element which will give energy to the circuit is known as active elements. Okay, example for the active elements will be voltage source and current source. Okay, let us consider a resistor. Okay, and apply a battery voltage of V volts, right? If we give this battery voltage only, current is flowing, energy is nothing but either I square R into T or V square by R into T, right? That means because of this presence of voltage only, energy is produced in the circuit, right? That means the element which will give energy to the circuit is nothing but active element. Here it is a voltage source. In place of voltage source, I can connect current source also. Okay, this is the representation of current source. Is is the source current. Okay, here it is the resistance R. Based upon this current source direction, current is flowing. Okay, that means the element which will give energy to the circuit, this is total is a circuit, right? The element which will give energy to the circuit is known as active element. Okay, now next, coming to passive elements, the element which will receives or consumes the energy, those elements are known as passive elements. See here resistor will consumes the energy from this source. That means here resistor is a passive element. Similarly, inductor and capacitor are the example for passive element. Okay, next coming to unilateral element. Okay, unilateral element is nothing but the element which will allow current only in one direction. For example, let us consider a diode. Okay, this diode, here it is a PN junction diode. Okay, this diode will allow current only in one direction. That means it will allow current from P type to N type. Okay, that means the element which will allow current only in one direction is known as unilateral element. Okay, bilateral, the element which will allow current in both the directions. Example, let us consider a same resistor. Okay, apply a battery voltage. Okay, minus plus, right? Current will flows from higher potential to lower potential. Okay, suppose if I change the supply terminals, starting minus and plus, again also current is flowing from higher potential to lower potential. That means it will allow current in both the directions. Those elements are nothing but bilateral element. Resistor, inductor, capacitor are the example for bilateral element. Okay, next, fifth one will be lumped parameters. Okay, lumped parameters means those are the network parameters which are able to replace it easily. Those parameters are nothing but lumped parameters. That means if we design one circuit, there we can connect resistance value and inductance value and capacitance value. Okay, if we connect a fixed value, 50 ohm resistor, 20 millihenry inductor, 10 microfarad capacitor is connected in one circuit. And again, if I don't want to connect those elements, then I can easily remove those elements and I connect in a different place. That means lumped parameters are nothing but those are the network parameters which are able to replace it easily. That means, for example, here 10 microfarad is damaged, then I can replace this 10 microfarad with another 10 microfarad. Okay, that is nothing but lumped parameters. Okay, next coming to distributed parameters. Okay, here in case of distributed parameters are the parameters which are unable to replace it. Those parameters are nothing but distributed parameters. Nothing but resistor, inductor and capacitor which are present in the transmission line. Already we know about transmission line, right? Every practical transmission line is having resistor, inductor and a shunt capacitance, right? But practically we didn't see individually resistor and inductor and capacitor, right? that means we cannot replace it indirectly. That means we cannot replace either resistor or inductor or capacitor. So we need to replace total transmission line. That means distributed parameter is nothing but those are the network parameters which are unable to replace it. That means here I cannot replace only resistor, here I cannot replace only inductance, here I cannot replace only capacitance. I need to replace transmission line. Okay, those are nothing but distributed parameters. Okay, next one, linear elements. Okay, whose elements which satisfies homogeneous principle and superposition principle. Okay, those elements are known as linear elements. Okay, the elements which satisfies homogeneous principle and superposition principle, those elements are known as linear elements. Okay, the elements which doesn't satisfy homogeneous and superposition principle are known as non-linear element. Okay, I think here you doesn't have some clarity about linear and non-linear, right? Okay, for circuits point of view, linear is nothing but, okay, let us consider one circuit. Here supply voltage will be 10 volts, R1, R2, R3, right? Here assume first case current flowing through this R1 will be 5 amperes. This 5 amperes is divided into 2 amperes and 3 amperes. Okay, now see here, if 10 volt supply will produce a current of 5 amperes, this 5 amperes is divided into 2 amperes and 3 amperes, right? Now if the supply voltage is increased by some constant K, that means if supply voltage is increased by 20 volts, then supply produced responses, the supply produced responses is nothing but current, right? This current is also increased by same constant K, 5 into 2 10, 2 into 2 4, 3 into 2 6. Okay, that means 10 amperes is equals to 6 plus 4 10, already satisfied, right? That means if supply voltage is increased by some constant K, the supply produced response is also increased by same constant K, then the given circuit is a linear circuit, then the given elements are linear elements. All resistor, inductor, capacitor are the linear elements. Hence every circuit will satisfy this condition. Okay, if supply voltage is increased by some constant K, the supply produced response is also increased by same constant K. Okay, that is nothing but linear element. Okay, from this again they may ask, what is meant by active circuit? Active circuit is nothing but the circuit which is having active element as well as passive elements is nothing but active circuit. Okay, this is active element, these are the passive elements, right? Okay, this total circuit is a active circuit. Okay, next coming to passive circuit. Suppose if he is asking passive circuit, the circuit which is having only resistors is nothing but passive circuit. Okay, this is the example of passive circuit. Okay, unilateral circuit, the circuit which is having only unilateral element is nothing but unilateral circuit. Similar way bilateral circuit. Okay, you are not required about circuits. Okay, next linear circuit. Linear circuit is nothing but the circuit which is having only linear elements is known as linear circuit. Okay, non-linear circuit, the circuit which doesn't have any linear elements, those circuits are known as non-linear circuits. Example, non-linear circuit is having diodes, transistors, etc. Okay, that is about network elements. Okay, remaining we will see in next class. Thank you.